on time. We are very grateful that we have Dr. Jonathan Liu here today. Dr. Jonathan is from, as you can see there, the School of Electronic Engineering and Computer Science at Queen Mary University of London in the UK. But is it, I think it's Professor, right? Prof, are you in the UK or in Beijing today?
Hello, hi Linda. I am in Beijing today.
There must be quite a time difference. What's the time there?
Yeah, it seems 6 hours ahead of your time.
Yeah, so we just come from a presentation that was quite a number of hours backwards, and now we're moving into the future with your presentation. So without further ado, we hand over the floor to you, Jonathan. Thank you so much.
Okay, thank you everyone. Thanks for the invitation. So here I'd like to share with you one work that we have done in advancing our assessment process for this particular subject, which is called embedded system design. So hence I came up with this title, Rethinking Embedded System Education with Generative AI and CDIO framework. So please let me take you through the challenges in teaching this module. This module is a third-year module of a 4-year degree program, which is called Microprocessor System Design. And we face these two these two fronts of challenges. One is that the challenges in developing graduate attributes in this area, which is the microprocessor system design, and also we have another challenge is how we deliver this program in remote destination. I mean, although Queen Mary is in London, but we have a teaching operation which is in China, so which we call it as transnational education, TNE. So microprocessor systems is a backbone of today's modern digital systems and is becoming increasingly complex. So, and also anyone want to be a profession in this area, they would of course have to go through formal education plus experience in designing such systems. So and our challenge is to ensure that the students actually attain the graduate level competence, especially in this area. And also the challenge is, and it is within a limited time frame. So after all, any modules that we teach or that we deliver is time limited. So, and in terms of the TNE teaching challenge is that we have currently 300 students, right? And it will be 600 students in 2 years' time, or in fact in next year, which become 600 students. So, and it is a third-year program or module in a 4-year degree program. Now, students do not have prior knowledge and experience in the holistic microprocessor system design. So meaning that some students may have here and there experience, but they never formally studied this subject. So, and also we have a very limited time contact and resources available while we are here in Beijing teaching. We normally would have only 4 teaching weeks. So because we do block teaching, and each of the teaching week is 5 sessions, and each session is 90 minutes. So you can see that the time is very limited. And students also at the same time attend at least 3 other courses in a similar delivery setup. And that also means that the schedule is very compact. But because the teaching is blocked based, students would have a lot of non-contact time available, meaning before we come back for the after 1 week of teaching, before we come back for the next week of teaching, the following block of teaching, so they have plenty of time in between. So we do need to find an effective approach in harnessing these non-contact time resources. So we came up with this approach, something called GenAI, which is Generative AI Empowered CDIO, referring to conceive, design, implement, and operate. CDIO-based authentic assessment with challenge-based learning. So, and that's basically the acronym. And this acronym referring to, as I mentioned, conceive, design, implement, and operate, it is actually an engineering design process, which is already quite well known out there. But what is the trick in this workflow? In this workflow, we argue that we should totally embrace the new generation of tool, which is the generative AI. So it is, in our view, Gen AI is a tool, and this tool is a very powerful tool where students can use it for various purposes, meaning for the purpose of knowledge exploration, for the knowledge of helping students to enhance the critical analysis, also as a tool to help students evaluate the design options, generating codes, troubleshooting, whatsoever. So, and the trick here is directly apply Gen AI into every of these phases through the entire engineering design process. And what is also a critical importance in how we make use of this CDIO process along with the Gen AI is that we have to create an assessment framework which is challenging enough that students cannot easily just use Gen AI to produce outcome without much of the high order thinking as well as a critical element in their design work. So in order to do that, we would have to create something called authentic assessment. So what does it mean by that? Authentic referring to the fact that the assignments that we give students has to be real world, has to mimic the challenges which is faced by the real professional. If let's say the profession is about designing a embedded system which is fully working, highly complex, and then here we directly mimic that environment in our assessment. And that also assessment should require the element of high order thinking among the student, teamwork, and collaborative learning, meaning that the challenge itself, which is in this case led by the challenge-based learning principle, that it has to be open-ended challenge, and also a challenge that promotes critical thinking, creativity, and innovative in the process. So this framework also grounded by some established learning theories. For example, constructivist learning, which is a process where allows students to actively construct knowledge. So meaning that the student may not have the full picture about how to approach the challenge. So, but they through this framework, they should allow to be independently unfolding the learning process. And Bloom's taxonomy is also a kind of pedagogical that allows students to build knowledge from ground all the way to the level, high level of creativity level. So I need not to go into the detail of that, but it is the learning theory that allow the scaffolding of the knowledge skills unfolding, so through towards the high order of the pyramid, which is the higher order thinking and creativity. And also this framework allows students to directly learn through the iterative experience, also through the reflection as well as the experimentation and so on. And this framework allows students to experience failures, experience difficulties, experience things that does not work straight away, and it should allow experience to scaffold and unfold. So and then build such experience, and then moving towards things gradually become workable, okay, and so on and so on. So, and that's involved a lot of that iterative process to get through. And also it is allows something called situated learning, meaning that the assessment allow the real world the scenario, and then also allow self-regulated learning, okay, because students can come from various background, various abilities, and so on. But the challenge is large enough, big enough, difficult enough for every member of our student coming from different background to come together and be able to demonstrate their own skill sets, and then also allow the critical reflection. So speaking of that, we, in order to support this kind of assessment framework, we adopt something called lean teaching approach. So the teaching itself is very lean, meaning we only cover all the basics related to the subject area. So if this subject area, what we call it as microprocessor system design, so hence we teach the microprocessors architectures, the coding, the environment, okay, and all the component related to this subject, okay, such as broken down into week 1, week 2, week 3, week 4. I'm quite careful about many some audience may not have this background knowledge about microprocessor system design, so I will just make it very quick in the sense that just want to introduce that our teaching approach is lean, meaning that we only cover fundamentals, but making sure that all students knows how to operate the design and implementation through the basics of all the fundamentals that they need to use in order to build the project that we install for them. And then for every week, we use something called coding day, which is a day where they don't study anything new. So meaning that we use 5 days, 4-day new material delivery, 1 day practicing that knowledge delivered in that week. So every week we have this coding day to practice directly what they have learned. Then this is the hardware that we will provide, which is the embedded systems. Okay, in here the processor that is based on the ARM processors. So students have to learn ARM processor architecture, the coding, as well as all the peripherals that is available on the board. And we also provide first set of hardware. So this hardware is directly used in this coding day. Then once the 2 weeks of delivery finish, we then create a little small project, which is what we call it as a mid-module project, where students start to make use of all the fundamentals knowledge that they have learned and trying to achieve this a small challenge. And that challenge is never been taught directly, meaning how to integrate all of these components, making use of the embedded peripherals. They are not directly taught. All they have been taught is the actual isolated knowledge and knowledge and skills related to every individual component. But they have to use what we call it as the Gen AI CDIO workflow to learn how to integrate all of this hardware and build a small system. And that system is simply just what we call it as the digital ruler. So meaning that using this ultrasonic to measure distance and then display it on the display board, and making use of this kind of peripherals, how to do some tuning and so on. So then we follow on another 2 weeks of teaching, which is week 3, week 4 component, which is the advanced level of component, and along with some additional hardware which is given to them. Now students have to pursue another challenge, which is the much bigger challenge, which is something called two-wheel self-balancing robot. So the earlier challenge was a smart ultrasonic distance approximator. In fact, whatever that they built here, which is the MOM project, is directly integrated with the rest of this hardware to form the so-called two-wheel self-balancing robot. So in here, there is these motors, they have these drivers, and then they have this gyroscope as well as accelerometer for the purpose of orientation, and then the Bluetooth interface and so on. And the higher level of knowledge includes something called free RTOS, which is real-time operating systems coding techniques to ensure that every operation is in real time, encoder reading, closed loop, PID control, all of this is not being explicitly taught in the program. So that means students have to independently learn this knowledge, also learn how to integrate them using this another round of GenAI CDIO workflow. So you can see that the CDIO workflow run in two lots. One is a 4-week sprint, another one is a 6-week sprint. So altogether is a 10-week sprint to reach the level where we want them to be, which is the level where they form this as a complete system. So here I have a little video which I'd like to show you the outcome of our framework. If you don't mind, let me play this. It's only 1 minute plus, if we still have time. So then the remaining slides are simply just the outcome. So let me see how I play it. Okay, give me a second. I just want to get to the point to play this. Oh, sorry, it's already jumped. So sorry. Okay, so it takes a bit of time. Okay, here. Okay, yeah.
Now we will start our EOM video presentation.
Sorry, can you hear the video voice? Just to check.
Yes, we can hear it. Thanks.
Okay, I will continue.
Here are all our group members. First, let's turn on the motor driver. It will also provide power for STM32 Now we connect Bluetooth with app on our mobile to control the balance car. Now we can use mobile to make the car go forward, go backward, turn left, turn right. OLED will show angle and distance data measured by MPU 6500 and ultrasonic. The data will also be shown on app on our mobile. When the car detects obstacle within 20 centimeters, it will stop. When the angle is larger than 30 degrees, motor will also stop. The button on the board can reset the MPU in case of emergency. When we were tuning PID parameters, we stopped 2 days trying to adjust the velocity parameters, but still not able to make it balance. Then we learned that we can use USB TTL to check the encoder data returned by the motors, and found out that our right wheel cannot return speed steadily for some reason, which may affect the PID controller results. So we use data from left wheel as data for both wheels in the PID algorithm, which solved the problem. We test the polarization of the wheels rotate in different directions and show it on OLED screen. This is for PWM control later on.
All right, so that's the video about showing students going through the entire process of the CDIO, the GenAI CDIO workflow, taking the experience of scaffolding the knowledge from the MO all the way to the EOM, as what you saw is actually the result of that achievement. So hence I call it as from zero to hero. So next. So this is an example of the documentation that the student has put together. This is just showing this particular group outcome. So I have nearly 50 groups doing this project. So so they have a various ability in putting together the videos as well as the outcomes as well as the documentation. So you can see the documentation is highly professional level. Comes in some minute level of details that the student have found. So this is just another some example of some successes. In fact, 50 groups of students all managed to get the two-wheel robot balancing all fully working, but not all students successfully scored high marks. So why? So that's the reason I would like to cover later on. So so the project marking is come with these criteria. So one altogether 6 criteria. So you can see that the CDIO operation, which where we focus a lot on the not the outcome but the process. So each of these is equally distributed in terms of marks. Then there is marks for reflection and self-assessment, reflection. So then another assessment is about teamwork and collaborative learning. So so this is the result that we have obtained. So the coursework is only 25% of 100% contribution of this module. So the coursework is only 25. Examination, which is closed for examination, is 75%. The coursework, we can see that the mean mark is quite high, 71% mean mark, but then the variation is quite high. From 52 marks to 86 marks, the marks ranging in such manner. So what I wish to say is that, okay, why some group scored so low while they managed to fully deliver the project, perfectly balancing the robot as well as navigating and everything. It is because the student who got such a low mark is because they did not able to show the transparency in how AI responses are being used and how much of the human intervention in the design, in the implementation, and so on. So hence, they have much relied on the AI, which maybe produce a lot of hard work, but then very little understanding of the whole thing. So hence, they scored low. Some who scored high, meaning that they have used AI to aid their design and implementation, even evaluation, they managed to go really deep in showing every little detail and so on, as the way we have shown seen in the video. So in terms of closed book examination is completely isolated from the coursework side, but isolated meaning that the examination is entirely based on paper form, where students have to demonstrate the understanding through written form. And the examination is historically the same and hasn't been changed. The only change is the coursework component, which is very different than the last cohort. So, but we saw a huge improvement of the examination ability, meaning students under closed book examination have demonstrated that they have a much deeper understanding of the whole embedded system design from the paper problems. Okay, so we can see some improvement of nearly 16 point of percentage. So we can see that the final grade distribution, students have shown a huge improvement in the overall grade distribution, a huge achievement. The closed book examination remain the main dominant component. So meaning that in order for a student to pass as well as to score high marks, the students still have to pursue this better closed book examination, not through the coursework. So this is to justify that such a high performance is not because of the collaborative work. It's all because of the individual performance in their own right through the closed book examination. But the coursework itself did help this personal improvement. So we can see the A grade now has actually improved by nearly 26 percentage point. And failure rate is reduced by nearly sort of 5.6 percentage points. So I meant to say that, okay, a lot of students have got better overall performance, okay, and the failure rate is reduced. So we aim to reduce this failure rate by creating such a authentic assessment that actually help the individual development. So, and the rest here is actually just a student survey. There are many questions here, 12 questions, and but overall mean marks is around 4 point something over 5. So we can see that high approval rate from the student as well. So I'm sorry for taking so much time, but yeah, thank you so much for listening to this presentation. Yeah, I hope that you have some questions for me. So.
Thank you so much, Dr. Liu. I think we run out of time because the next session is already starting, and I know that people are keen to attend. But we do have your contact details, and we'll be certain to be in touch. I love the focus on process rather than product. And this from zero to hero approach beautifully captures that sense of transformation that we want our students to go through. So thank you very much for this very exciting and inspirational talk, and good luck with the project going forward.
Yep. Thank you so much, everyone, for listening, and then thank you very much for giving me this opportunity. Thank you.
Absolutely. I'm sorry that we didn't have time for more discussion. We'll get you back for next year. You can come and tell us again.
Yes.
Thank you so much, guys. We'll close the session now, and we'll move on to the plenary discussion in the program. Thank you. Bye-bye.
Yes.